In this video, we're going to look at intersecting oblique planes, and what that means is that up until now, we've always looked at oblique planes where we only had one. So we only had, say, the red one here or the yellow one. But now what we have is we have two oblique planes, okay? And what happens with these is that they can intersect each other. And what we want to find is we want to find a line where they intersect each other, which is called a line of intersection. And then we have a few things that we can do with that. So we can find the true length of that line. We can find the dihedral angle between the two planes. The dihedral angle being the true angle between the two planes. Okay. Now, what you need to notice here, first of all, is that when you have an oblique plane here, so you'll see you have the red one, VTH, and you have the yellow one here, VTH. The line of intersection here crosses there starts at the point where they meet at the vertical plane and ends here at the point where it hits the horizontal plane, okay? Which makes it quite simple to then go and to try to find that in a question that we're looking at, okay? But what's also important to note is that these planes can go on to infinity, but we only work with it in this space. So that's why we can say that it starts at the vertical plane, ends at the horizontal plane, even though it actually could go on a little bit further if it needed to. So here we have an example then in practice of what that actually looks like. And what you'll see here is that we have a vertical trace and a horizontal trace for our first oblique plane, and we have a vertical trace and a horizontal trace for our second oblique plane. Now in this view, they're not extended on, so they don't appear to be crossing. But if we go over to the example here where it's actually drawn out, you can extend on your vertical trace as far as you want. You can extend on your horizontal trace as far as you want, and then you can do the same for the other. And what you get is you get 2 points where they meet. So you get Q here in the elevation. And what we know here is that Q is on the vertical traces, which means that it has to be on the vertical plane. And we see the vertical plane as the XY line in the plan. So if I bring down Q straight down, I find Q in my plan by just bringing it to the XY line, because again, we know that Q is on the vertical plane, okay? And that's the vertical plane in the plan. What we then also get is we get the point P down here in the plan. And we know that because the point P is on the horizontal traces, we can then say that the horizontal plane, so the horizontal traces are on the horizontal plane. We know that the horizontal plane is the XY line in the elevation. So if I bring that one straight up here, I can then find my P1 up here in the elevation. And what I know is that the line of intersection goes from P to Q. So that's P in my plan going, or sorry, that's P in my elevation going up to Q in my elevation. And then I have my Q in my plan going down to P in my plan. And that gives me a line of intersection. So I have the line of intersection in the elevation, and I have the line of intersection in the plan. Now, once you've found your line of intersection, then we can use that to do some other things that we might need to do later on. Now, what you see here is that it's giving us two alternative methods for finding the length of the line of the true length of the line of intersection between two oblique planes, and you'll see an alternative method for finding the true length of the line of intersection. We're actually going to use neither of these methods, okay? Because what we'll be doing is trying to find the dihedral angle, and for trying to find the dihedral angle, there is a third way for finding the true length of the line of intersection. So we're not going to use this one, and we're not going to use that one. They are perfectly valid ways of doing it, but it just means that we have to learn a different way of doing the dihedral angle, which we are not going to do. So we're going to use a third method for this, okay? So if I go down a bit further onto page 160, what we're asked to do with this one is that we're asked to find the line of intersection between the planes and then determine the dihedral angle between the two planes. Now this is very similar to the example a second ago, and you'll see here is the three-dimensional view of it. And you have your vertical traces crossing and you have your horizontal traces crossing, okay? And you'll see that they found the line of intersection the same way. Now what they have here is that they have a lot of construction going on, okay? Now again, we're not going to use this construction. We're going to go down and we're going to look at this method, okay? Now this method basically shows us how to find the true length of the line of intersection, as well as how to find a dihedral angle. And the reason that we use this method is because this method uses auxiliaries, and auxiliaries are what we use to do all of the different things that we're going to be doing in DCG, okay? Because it's the method that can be used in the most different the most different circumstances. Okay, so what we have here is that if we want to find the true length of the line of intersection, we first of all have to find the line of intersection, which is here. So we have this line is line of intersection and this line is line of intersection. So if we want to find the true length of it, what we need to do is we need to take an auxiliary looking directly in at it, okay, and find our XY line. And then because we projected from the plan, we're going to be taking our heights from the elevation, and we then get the line of intersection, the true length of the line of intersection down here, okay? So by taking the x1, y1 line parallel to the line of intersection in the plan, then taking our distances from the elevation, so our P1 on the ground and our Q up the distance from the XY line up to Q, we get the true length of the line of intersection. Then the next part is to go and to find the dihedral angle between the two shapes. Now, what the dihedral angle means is the dihedral angle is just the true angle between the two planes. So to be able to do that, we have to look directly in at it. Now, what you have with this is that the next step is to look along the true length of the line of intersection. So what we do with this is we're going to look this way, okay, to find this auxiliary. So the x1, y1 line here is perpendicular to that line, okay? So we have perpendicular here, true length to the x1, y1 line, okay? Now what this does is that it gives us the true length of the line of intersection as a point, okay? Now, because we're looking for the dihedral angle, if we see the true length as a point, it means that we're looking directly in along the two planes. Okay, so we're looking directly in at them to be able to find where the dihedral angle is. Then what we can do is we can take our distances, as we said before, from an x1, y1 line. Well, this is an x2, y2 line. We'll go back 2. So if I want to find the distances for this, I'm going to go back 1 view and 2 views, and I'm going to take my distances between my 1 and 2. Okay, so if I wanted to then find my distances for this, I would take them coming back into this view. Now, the problem that we have is that we don't have any kind of particular points that we can kind of use for to find my B and my A here, because when we project these down, we're not really using the traces as they were going to be used. So what we've just done here is take two random points here on the horizontal traces to be able to find those heights. So what you have here is you have A and B, okay, which are just 2 points that when they were doing the question in the book here, they chose at random. Okay, they don't need to be in particular places, but they need to be on the 2 planes. So we have A, which is on the first oblique plane, and we have B, which is on the second oblique plane. Okay, and because A and B are on the ground, okay, so it's on the ground because it's on the horizontal trace, we have A1 ends up being here in my auxiliary, and I have B1 ends up being here in my auxiliary, okay? And then when this comes down over to my auxiliary, my x2, y2, so my second auxiliary, what you'll see they've done here is that they've taken a datum line, okay, which you've been used to using before. So they have their line taken here, which is just a datum, which all it's done is filled in this gap, so we don't have the big gap. If you didn't put the datum line in, you would be putting your compass on the x1, y1 line and measuring it back, so this would end up further away. But this datum line just puts it closer to the x2, y2 line. Okay, so that's my datum line. So then they've said that B is on the datum line, so B is here, and then A is just taking the distance from your datum line up to your A, which gives you your A. And then that gives you your points that allows you to actually go and to find your dihedral angle, okay, when it comes to looking at it. So with that, again, just a quick recap, you have for your dihedral angle, you are going to find your line of intersection first. You're then going to find the true length of that line of intersection, okay, using your first auxiliary, which is going parallel, or your x and y line is parallel to the line of intersection in your plan. And then what you're going to do then is look along that true length of the line of intersection to find it as a point, which then allows you to draw your 2 oblique planes in your auxiliary down here. And in order to find distance for those, it's just taking 2 points, 1 point on one of the horizontal traces and the other point on the other horizontal trace, and then using your distances then in this case with the datum line doesn't have to be there, it just means that this ends up being on your x and y1 line rather than being too far over here. Okay, so they're the things that we have with our oblique plane. So we have to find, if we have two oblique planes that are in contact with each other, we have to find the line of intersection first, then we'll often have to find the true length of that line of intersection, and then the dihedral angle, which is the true angle between the two planes.